Welcome everyone. Hi, it's Georgina Smit. I head up the technical team at the GBCSA and I'll be your host for today. And welcome to the Planet Shapers online event. We've got a very exciting topic today. It's the role of the first fuel in battling South Africa's energy crisis, which we know is at the forefront of everyone's mind. We're all experiencing it. We're all very frustrated about it. We've all got lots of thoughts and opinions about it. But today's session is really about understanding what some of the solutions are. And we've got a very specific focus. So we've got a great panel that will be sharing some thoughts today. We've got, and I'm going to go from left to right from who's on my screen. We've got Lagrange, who's head of department at the engineering department at the University of the Free State. We've got John de Wet, who's the environmental sustainability manager at Stellenbosch University. We're also joined by Grahame Cruickshanks, who's head of sustainability and utilities at Growthpoint Properties. And we're also joined by our own CEO, Reynolds from the GBCSA. So, as I said, today's session has got a very specific focus. Looking at our energy crisis, we want to understand what is the role of energy efficiency. So there are many solutions that we have for our energy crisis. We know and we acknowledge the role that renewable energy generation and just generation and supply plays, looking at IPPs, looking at all of our purchasing agreements and wheeling agreements. But today we're looking at the other side of the coin. We're looking at how do we make sure that we don't need as much energy. And today's session is also going to be solutions focused. So I would welcome everybody to put any comments or any questions down in the questions bar, please, and we will answer them. So Louis is going to give us a presentation about some key concepts to set the scene around energy efficiency, understanding where the opportunity for change is and what the potential for energy saving is if we get energy efficiency right. And then after Louis has done a presentation, we'll open up the floor to the panel. We've got some questions, but please also put your questions down, and we've got enough time to kind of go through everything. So I think maybe just to give some background intros to our guests. Louis is an agricultural engineer by training and actually worked for Agrileg, which was a subsidiary of Eskom many years ago, but has subsequently entered the tertiary institution as a lecturer and now heads up the engineering department at the University of Free State and has done a lot of exciting research on energy efficiency. Then John's role as the sustainability manager at the University of Stellenbosch requires looking at all sustainability related items across all 4 of the campuses, and he oversees a portfolio of 460 buildings. Grahame, who is an architect by training and previously was a managing executive at the GBCSA, and prior to that, the manager of the climate change team at EY, is now responsible for overseeing all of Growthpoint's properties sustainability considerations, and that's both from an energy efficiency but also from a supply side. And Lisa, our CEO, has got a long history with energy efficiency, particularly in terms of driving the standards and our legislated standards in South Africa that have called and implemented higher standards of energy performance requirements within buildings, and has really been instrumental in driving that conversation. So welcome to all of our guests, welcome to all of our listeners. I think this is going to be a great conversation, and I'm going to hand over to Louis now to start his presentation, and the rest of the panelists can switch their cameras off, and then we'll come back on once Louis has finished with his slides. Thanks, everyone.
Thank you, Georgina, and thank you for the panel that is here with me today. And I am going to do a couple of very unusual things today. I'm going to make a couple of statements, and I hope that you will be able to follow why I'm making those statements. My name is Louis Lagrange. I'm also not only head of department at Engineering Sciences at the University of the Free State, but I'm also the presenter of several energy management courses in South Africa. So I've got 15 years of trying to, or trying to actually convincing people to look differently at energy. So I'm going to make the following statement. You are not powerless. We can go further and say, we are not powerless. And we can go even further and say, I'm making the statement, South Africa is not powerless. So today, I'm going to spend a little bit of time with you to change your way of thinking, or to give you a mindset, what to look for and how to look for it to unlock energy management opportunities. Many of us would know the Chinese sign for crisis that consists of two different separate sections, of which the top one in isolation spells danger, and the bottom one in isolation says hidden opportunity. Now, I'm pretty sure that Winston Churchill, who's quoted that don't overlook the opportunity in a good solid crisis, got it from this specific sign. Let's look at what we need to do today. Before I can do anything, I want us to understand on the theme of today, what is the definition and the context of first fuel and what is an energy crisis. So today I'm going to delineate this discussion and make sure that we don't go over the boundaries. Otherwise, we need 3 or 4 or 5 days to do this. And I'm going to focus on specific things. So today I'm going to focus on the first fuel is the first step to produce usable energy for human consumption. So I'm going to look here on the right-hand side, on the red, how we use primary energy sources to generate electricity. And although we are going to focus today specifically on fossil fuels, the concept and what we're going to discuss today will be equally as applicable to other forms of energy as well. We are not going to discuss today the just energy transition, because that is the shift from traditional fossil fuel-based systems to more sustainable renewable energy sources in a way that is equitable and fair for all members of the society. So we're not today taking into account the social, economic, environment impact, energy poverty, and creating job opportunities. Although what we're going to do today will have an effect on it, will definitely have an effect. The next question is, what is an energy crisis? Now, I call an energy crisis a AAA situation. Now, in my life, a AAA situation has got far-reaching consequences. That's a serious thing. And here we're looking at the availability, the accessibility, and the affordability of energy resources. Now, it's a crisis when these three become either severely limited, disrupted, and you can have lots of significant economic, social, and environmental impacts. So if we want to address that, we can address it on short-term measures and long-term strategies. And today, another delineation is we're going to look at the short-term measure to alleviate the immediate effect. Now we can start asking ourselves, do we understand how to measure energy? Do we understand energy metrics? And do we know about the concept of MUDA? MUDA, MUDI, and MURI, which is used in lean manufacturing, specifically in Japan. Let's see what we've got there. An analogy. I love analogies. I have an available amount of drink, non-fermented soft drink, by the way, ladies and gentlemen, and I have 2 liters at the moment. So I am concerned. I would like to know how much of the 2 liters am I pouring out and how much have I poured out, because that's the amount that I pay for. So let's say I've got a quantity of 2 liters. I pour it out at 0.25 liters per second. That is per time unit. So that's a rate. And then we have liters per second. And then we have how long do I do it. So these are the 2 metrics for today. How fast are you using your energy? In this case, the drink. And how long do you use it? So if we multiply the 2, we multiply liters per second by the time in seconds, we get that although there are 2 liters in the bottle, the quantity for this time is 1.5 liter. So I can say that I have to pay for 1.5 liters of soft drink that has left the bottle. Now, interesting enough, if I start to measure and I find that the useful drink that I've received in my stomach is only 0.5 liters. So there's my third metric, the green one. I measure only 0.5 liters has reached my stomach. I say, this is what I get, but I've paid for 1.5 liters. That means that I have somewhere along the line lost 1 liter. I've paid for it, but it's gone. And that's what the word mira means. You have paid for something, but it doesn't add value. Let us change from liters and drinks to the terminology of energy for today. So there we have a quantity of energy which is normally measured in kilojoules. The rate that you're using is kilojoules per second. So you're supplying at a certain kilowatt. You multiply by the time. In this case, we're going to multiply by an hour, which is 3,600 seconds, and you get a quantity of kilowatt hours. Can we just quickly focus here? We have kilowatt, which is a rate, and we have kilowatt hours, which is a quantity. Those are the two things. And you multiply kilowatt with time to get to the quantity. I then call, instead of drink reaching my stomach, I call it useful energy at the point of use. And I've put it in green. So what you pay for is in blue, what you get is in green, but at the same time, you have lost along the way during that transition from getting out of the bottle or the kilojoules to reaching your point of use. If you measure, you have some waste kilowatt hours. They just gone. They have been transformed into another form of energy. That's what we call mira. So there we have mira is waste which you pay for, but it doesn't add value. You actually throw that money away. And the 5 big questions that one should ask if you do energy management is, how big is the mira? Why do you have the mira? Understand why the mira is there. Then you ask the questions, can we avoid the mira? Can we minimize the mira? Or can we recapture and reuse the mira? Those are the 5 generic questions that any energy manager should ask in that sequence before they can do anything about energy management. I hope this was of value. Now we understand we have kilowatts and we have time. Let's see what are the tools to measure energy. There we've got the tools. On the one side, we have kilowatt, which is the rate of use. And at the bottom, we have the hours. And we have seen that if we multiply them, kilowatt with hours, we get a quantity in kilowatt hours. So visually, the blue block on the screen can tell you this is the amount that you pay for the energy. Okay. There's our metric 1, kilowatt 2, 1, and kilowatt, and metric 2 in time. There is, if we want to reduce it, we can either reduce the kilowatts, or on the right-hand side, we can reduce the time, or we can reduce both of them. So the tools that we have available now for energy management is kilowatts and the time. And the interesting thing is that when we do the energy management training courses, we then add, of course, the cost of energy in rand per kilowatt hours. And we're just talking here about blended cost at the moment. If we then understand the 2 tools, kilowatt and hours, what are the drivers? How are we supposed to use that in our everyday life? So first of all, the time. The time is driven either by humans, you switch on and off, or by controls to switch on and off. And on the left-hand side, the kilowatts is generally speaking driven by technology, different types of technology. Now, how did we address this in the past? Increase the capacity. Very easy, very simple. Increase the capacity, build more power stations, and everything is sorted. That is not on the table anymore. And these are the 2 things that we're going to discuss today. Let's just look overall at South Africa's total installed generation capacity. There are various different figures. These comes from the CSIR, 54 gigawatts as of a month ago. The coal-fired, we're going to focus a little bit on that, installed capacity is 39.8 gigawatts. But we don't have the 39.8, we don't have the 39.8 available because we have an available factor of 50 to 53%. I've been very generous. I've said we've got an availability factor here of 58%, which is 21 gigawatts. And don't worry too much now about the exact figures. It's a concept. So our electricity demand at the moment is around about 35 gigawatts. So somewhere between 35 gigawatts, which is the red line, which we want to be, and 21 gigawatts is where we are at the moment, there's a deficiency. So that green or that yellow part tells us this is where load shedding has to happen. And we know that load shedding is an emergency procedure. It's like cutting off the hand to save the body. It's an emergency procedure by actually making a lot of damage in order to save the rest. Just before we go on, look on the right-hand side top of the screen. That is 78 gigawatts that South Africa will need according to traditional methods of determining that by the year 2030. I'm not even going to say we are going to get it or we're going to try to get it. What I'm going to focus is what can we do today and tomorrow to alleviate this yellow part. We also know that it's not always a straight line. If we now add the renewable energy capacity, our available capacity can look like that, but this is not part of today's discussion. What I've done here is I want to discuss demand side management, or it was just before Eskom closed it down, called integrated demand management. So typically, there we have our coal-fired capacity in green. Now, our electricity need is not a straight line. So I just put a line there, just for the sake of explaining it to you. So everything above the green line says we don't have enough capacity for the need, and that's where we start with the rolling load shedding. However, if we do energy efficiency, which we're going to do today, we lower the kilowatts. Look at that black line. So if we decrease the kilowatts, typically by technology, we can actually lower the amount of times where we need load shedding. And I think that can be seen very clearly on the screen on the left-hand side, if you follow my arrow, and here on the right-hand side. So energy efficiency is one of the most ideal ways to address our current crisis situation. But if we take energy efficiency and we add time, and the purple line that you see going in there, of course, it's just a Louis line for illustrative purposes, we can get to a situation where we do not exceed our capacity, which means we don't need any more load shedding. This is the theory. And here we can see that we've got kilowatt on the left-hand side and time on the right-hand side as our tools. So let's say, for instance, I'm going to first talk about reducing the kilowatts, how to reduce a kilowatt. I'm not going to address immediately how to reduce it. Let's get a little bit realistic and say, the theory that we've got here, how does it look in real life? The first thing is you need to understand the flow of energy. Here the energy flows from the coal. We've got an efficiency of 30% there, converting coal into electricity. We transport the electricity, 90% efficiency. It comes into my factory, 85% efficiency through the electric motor, 65% efficiency through the pump and the drive, 30% efficiency there through the valve, and 95% efficiency through the water that has got friction. So at the bottom, we have a boundary of interest for the society, the entire long greenish, yellowish part. But there is on the left-hand side in blue, a boundary for the electric utility, which I can't control. So I am looking for what is under my control. And there it has come in. How much do I pay and how much do I get? That is my efficiency. And if we look carefully there, what I can control is the end use, the application, and the input to the machine. the pay relative to the gap. And in energy management, you always have to do the calculation from the get side, from the end use side. You always do the calculation backwards. Let me explain to you how important and how incredibly effective it can be to help you and, of course, the entire South Africa if you understand these efficiencies. I'm looking at an efficiency of 30% of the valve. That brings me to the story of valves and pumps. In my next life will all be see-through, so I can see what's happening on the inside. The way that we can look at this is, if it's 30% efficiency, it means 70% MEDA. 85 means 15% MEDA. Let's break this down. If we look at the overall system, on the left-hand side, with a gray block that comes in, you pay for 100 units of energy, which is embedded in the code. But you only get on the right-hand side in green, the end use is 4.5% useful energy. Now, using the Sankey diagram there, I can see that 70% of what I pay for gets blown into the air by Eskom in the form of heat, but I still pay for it. So that's MEDA. If I have, however, look on the right-hand side, I say, wait, the valve there, I've got some control there. I can do something on the valve. So if I select the valve there and I maintain the valve, I can even replace it if necessary. But let's say I've maintained it, and the valve goes up to 70% efficiency. I have taken away the MEDA. The end use, ladies and gentlemen, on the right-hand side is now 9.9%. So you have reduced your MEDA substantially. Now, this is important for the entire value chain if you look at it from beginning to end. If I hone in and say, wait a bit, Louis, I want to look only at what's more under my control inside my factory, which is the blue block that comes in. I'm going to focus only on that. So let's do that. There's a blue block. I still have on the left-hand side energy coming into the meter. But looking at this, and I determine it by multiplying the efficiencies with each other, there's my meter input. For every 100 units that I pay for, I now get 15.75 units of end use. Now that looks a little bit better. However, the Sankey diagram shows me there's still MEDA, the red part, the valve. So let's go and change the valve. So we want to change the valve and maintain the valve, and we change the valve from 30% to 70%. But before we change it, let's look at the calculation. I do the calculation from the back part. I get 1 unit of work out. That doesn't change. But for this specific situation that we've got here, I pay for 3.7 units of electricity or energy for every 1 unit that I get out. Please remember this. I always get 1 unit out. So the moment I reduce the MEDA, my 1 unit that I get out stays the same. My pay is reduced. Let's go through the thinking process before we start with some actual figures from examples in real life. I change the valve to 70%. My end use goes up to 36.75%. Wow. Now I'm looking, okay, that's 70%. What can I do for the electric motor and the pump and drive? And in many cases with the pump and drive, a little bit of TLC on the drive and maintenance on the pump will go a long way to increase that efficiency. And if I do those two, I identify those two, and I change them to an electric motor of 90% efficiency, the pump and drive of 75%, my end use now becomes 44.9%. And you can see there is not a red line here anymore. So there's not a glaring, obvious MEDA anymore. Let's put this in context. I still get 1 out. That hasn't changed. But now I change that and I pay only for 2.2 units. Ladies and gentlemen, what is the effect of this? All of this says I've saved 1.5 units on my cost of paying for electricity. This means that I will have a 41% reduction on my energy bill. This is the reality of the calculations that we've just done now. I hope this will let you sit up. Say 41% reduction on energy bill. Is this human being really telling us the truth? The answer is yes. let's, to conclude, see how to apply the tools. What is the efficiency of the energy conversion? So we know we've got the 2 kilowatt, we've got the hours, we know we've got efficiencies, and that tells us how big is the meter. So let's reduce it through reducing through technology, the kilowatts. So what we're going to do here is we're going to see how to lower the kilowatts. There's an incandescent light bulb. It gives you 5 units of light and 95 units of energy, heat energy out. That's not a light bulb, it's a heater. That means for 5 units of light, you pay for 100 units of electricity going into the bulb. And there, if you work backwards, you pay for 360 units of energy embedded in the coal to get 5 units of light out. That is shocking. Let's now go to a fluorescent light bulb. Now, fluorescent light bulb works on 45 to 55 units of light. I'm erring on the positive side here, 55 units of light, 45 units of heat coming out. If I now say, I don't want 55 units of light, I don't want more light, I want the same light. So I want the same lux coming out, or the same lumens, I apologize. For 5 units of light, I now receive and pay for 36 units of electricity coming in, but actually, I'm paying for 132 units of the energy in the coal. So I've gone from 370 in the coal to 132. Let's change this to an LED. Now, LED typically, these are average figures, gives me 20 units of light and 20 units of heat. If I work that back to 5 units of light, because I want to compare it with my first one, what I get there is I now pay only 6.2% units of electricity. That is on my bill, and you pay 23 units of energy in the coal. Ladies and gentlemen, that is how you do energy management, working backwards to make sure that you still get the same out, you get the same, but how much do you pay? You pay now only for 6.2% of what you used to pay for an incandescent bulb. Now, I would like to say that is substantial in capital letters and in red, underline, and bold. Let's see if these figures look vaguely familiar or is happening in real life. I've got T12 fluorescent tubes. Remember, with the fluorescent tubes, I've already gone from incandescent to fluorescent. There we've got 500 lux that comes out. I go to T8, also 500 lux, but I go from 144 watts to 60 watts. If I put in light emitting diode tubes, I can go to 36 watts. With LEDs, I can go to 550 lux, which means I get a little bit more, but not all that significant. But I'm now down to using 25% of my 144 watt where I started. I've reduced my energy bill effectively by 75%. Now, the problem that I have, people tell me, Louis, we've put in LEDs, we sorted. That is not true at all. You're not sorted. You've just done kilowatts. You haven't done the human side. You haven't done the control side. So there's just a typical example. This is from the CEM course. Before 72 watts, after 36 watts, just by changing the bulbs. Then we've got a store, 40 watts, 400 watts on the left-hand side, on the right-hand side, 150 watts. Better visibility, different color, correlated temperature, 37.5%. Those things are in your hand, but I'm making the statement, it's not yet good enough. It helps South Africa, but you can help even more. How can we apply this then through changing the time? That's humans and controls. Let's look at that. We now have done on the left-hand side an example, on the right-hand side, driven by humans and controls. We are going to focus what we can do. And please remember, by changing the hours here, on the top of the hours here, where I'm circling at the moment, you can have an effect on the kilowatts as well. Let me give you an example. We've put in LEDs, the light-emitting diodes, the tubes. We've already reduced the red lines. We've reduced 75% of our cost. If we now go to the control side, we can put in what we call task tuning. So we reduce the lux levels and we put in task lights where it's necessary for the humans where they need it. So there's just an example. You can then reduce the kilowatts and the kilowatt hours. Okay. We can do scheduling. And scheduling, you will see there on the bottom coming up, switch off the lights, all the lights, when it's 12 o'clock at night until 4 o'clock or 5 o'clock in the morning, depending on how early you start to work. There's another saving, and that's in kilowatt hours. It reduces the hours, but it doesn't reduce the maximum kilowatts in the middle of the day. We can do daylight harvesting, and daylight harvesting will typically look like that. I'm going to let it come in again. So with daylight harvesting, you reduce the lux levels of the lights, in other words, your cost, by harvesting the light that comes from outside, of course, taking into glare and all sorts of other things as well. Then we can have occupancy sensors. Now, with occupancy sensors, you can go further and put in vacancy sensors and save another 7%. Vacancy sensors, occupancy sensor says, switch off after a time if there's no movement, and then switch on when the movement is there again. Vacancy says, I work by switching off, but I don't switch on again. You must press a button to switch me on. Now, I've put them together, and just by putting them together, you can see on the right-hand side, I have suddenly reduced my kilowatt hour as well as my kilowatts by doing that. The last one here, that's just an example, personal control. I haven't even put it on the graph, but on the graph visually, you can see that after you've reduced 60% or 75% on your kilowatts, there are still a number of other tools available, cheap tools available for you to save energy. So for the specific example that we've got here, that comes from the Certified Lighting Efficiency Professional course, the network controls caused another 60% reduction. Now, I call that 60% substantial, and it's available and it's practical. We can reduce our airflow in heating, ventilation, air conditioning systems. Now, ladies and gentlemen, if you reduce the airflow with a variable speed drive, and you reduce the airflow by 10%, by reducing the speed of the centrifugal fan 10%, the theoretical reduction in energy use is 27%. But taking all practical things into account, you can reduce your energy use by 21%. Now, just say before 10 o'clock in the morning, or until 10, 11 o'clock in the morning, you just reduce the airflow by 10%. You have taken into account that there's enough oxygen and everything. You can have an energy reduction of 21%. Of course, when we talk about this, there's a capital cost involved here, and you need to determine the feasibility by using metrics like net present value, life cycle cost analysis, and internal rate of return. Let's end off with a couple of passive applications, especially for buildings. This comes from an overseas publication. This is not my own figures. Our own figures that we've done here at the University of the Free State, we've run it for a year and a half now in schools, are not yet available for publication, unfortunately, but it's the same concept. On the left-hand side, you've got 100% of energy coming in. By putting in an internal blind, in other words, you've already allowed the energy to come into the building, and then you put a blind, you can reduce your energy by 17%, which means the heat that comes in, you don't have to remove with the air conditioning system. We can put in solar protection glass, and you have different classes of glass, and you can then reduce it by 20% up to 56%. There's the last solar protection glass. You can put an awning on the outside, just an awning, and 60% reduction. And with the awnings, I also teach you in my different courses that the awnings needs to be in 3 different configurations on each different western, eastern, and northern side of your building. Not only an awning, they need to be in different configurations. 60% reduction in the amount of heat that you have to remove. This is the same study, and just to show you the concept, because I'm going to the concept, can you receive the reduction in energy from 540 megawatt hours down to about 150. This is one of my last slides. There is typically just an example as well. A heat lost. You've got a pipe at 185 degrees Celsius and you have no insulation. And when you put up any insulation, the rule of thumb says that you reduce the MEDA by 80 to 90%. Let's look on the right-hand side. We've got the same graph there. What I'm saying at the moment is, if you take the cost of the insulation, the thickness increase, we have that blue line. We have on the red line, the reduction in MEDA. That's a reduction in the waste, which you pay for. And you not only pay for it, you pay for it right through to the energy that's embedded in the coal. And if we add the two together, we get what we call an optimized curve. And this, where they are basically at the lowest part, that's an economic thickness. But when you come to the course, I'll also teach you to look at the different angles here, because the different angles tells you in which direction to move as well. So this course, or this webinar today, is just to introduce you to a couple of things. That was passive applications. Ladies and gentlemen, to conclude, you have the following energy management tools. You can change the rate of use, the kilowatts, primarily with technology. On the right-hand side, you can reduce the amount of time, primarily by controls and through humans as well. Switching off, of course, saves the most money. And on the right-hand side here, where I'm circling at the top, by switching off here or by reducing the hours, you can also at the same time reduce the kilowatt. That concludes my part where I've introduced the two tools, kilowatt and hours, where I make the statements that is under our control. We can use technology to reduce the kilowatts, and we should use controls and humans to reduce the hours. And I then say, we don't have a shortage of electrical energy in this country, ladies and gentlemen. We have an abundance of MEDA, which is wasted. Focus on the MEDA, focus on the waste, and we'll have a good life. Thank you very much, Georgina. That concludes my part of this webinar.
Georgina, we can't hear you.
Okay, Georgina, we want to hear you, but we still can't hear you.
Okay, I think let me jump in while Georgina's sorting out her technical problems. And I'd like to invite John and Grahame back on line to show their gorgeous faces. I think we...
Guys.
Yeah, you're back. Cool. I'll hand back to you.
Thank you, Lisa. Louis, I was saying thanks so much. I think that there was some really interesting numbers there and significant potential. I remember doing a course when I did my master's through Growthpoint at Stellenbosch, and all those numbers were coming back to me about all the efficiencies and the loss, and it is big. It really is significant. So thanks. All the panelists have put their cameras on, and we're going to go into a discussion session now. We do have some questions. I don't see many from the audience, so guys, please jot some questions down if you want. For those who maybe joined a bit later, just as a reminder, we've got Louis Lagrange, who's from the University of the Free State, head of the engineering department. We've got John de Wet, who is the sustainability manager at Stellenbosch. We've got Grahame Cruickshanks, who's the head of sustainability and utilities at Growthpoint, and then we've got Lisa Reynolds, our CEO. So Louis, I think your opening statement of us not being, powerless was, really has set the scene, and I think that that's going to be our kind of focus for today and for some of our questions. And so obviously, we have this challenge. We have to cut emissions. We know that, but importantly in South Africa, we need to provide a secure supply of energy, and we need to grow our cities. And if you look at the kind of landscape and the types of things that are trying to improve energy efficiency, we've got our building standards. Lisa can talk a bit more to those. We've got an understanding on performance targets and disclosing that information. That's kind of where the GBCSA has played in that space in terms of certification tools. There are things like incentives, showcasing examples. But I would be interested to hear from the panel, so from John and from Grahame and from Lisa, after listening to what Louis has said and from setting the scene, do you think within your respective perspectives, so the perspective of a property portfolio from Grahame and from a university campus manager, and then from the GBCSA as an as an NGO advocating for efficiency, do you think enough is being done about energy efficiency within the realm that you have influence over and control over? And then what do you think needs to happen to improve awareness of energy efficiency at a national level so that we can deal with the energy crisis? So I think maybe if I could, Grahame, if I can put you in the hot seat and just get some of your thoughts first, and then we can hand over to John and then to Lisa, please.
Sure, thanks, Georgina, and thanks, Louis. I think you asked the big question around whether or not enough is being done to create the right level of awareness and understanding of the role of energy efficiency in dealing with the crisis that we're currently faced with. Very few people have Louis' ability to unpack the scenario that you're currently faced with. Nonetheless, many people stand around the braai, sit around the dinner table, and discuss this issue. So I think that the audience that we're dealing with at a national level is extremely receptive to be able to respond positively to any information that is fed. I think the critical thing is to divide the actions up and the calls to actions up into the right categories. So, I think what comes to mind quite often first in a knee-jerk reaction is business continuity or operational continuity. And that is why we're currently being faced with the swing to generation, I believe, because it's the quickest way to address continuity problems. If we have a client, a tenant who's struggling to operate because they haven't got a power supply, we need to fix the power supply problem immediately. And so we then need to understand what the foundation of the situation that we're faced with is versus the current hair on fire problem. And the foundation that we're faced with is how to put in place the kind of initiatives that Louis was talking about. So to the big picture question, no, I don't think we're doing enough to communicate at a national level about what actions are required, what's appropriate, and what's going to bring about the kind of changes that we need. And then when it comes to portfolio management that you were just alluding to, Georgina, we're operating on a very similar level. The knee-jerk reaction versus the foundation problem. And I think that for us, the one thing that Louis didn't elaborate on too much was the role of monitoring and verification in creating the kind of information sets that can be communicated, whether it be to our own people, Growthpoint staff and employees, or to our clients, our tenants. And I think we can maybe elaborate on that a little bit later on, but I don't want to steal any more of the panel's time at this stage. So I think that's hopefully gives you a bit of a response to your first question.
It does. Thank you, Grahame. John, I'm going to hand over to you for your insights.
Yes, thank you very much, Georgina. So we're dealing a lot with students and with staff, and as you know, business must continue. So what do? We actually don't save, we add to the problem, we add generation to the problem, diesel generation, which makes actually the problem much more difficult, and it actually pushes up the cost because it's one of your most expensive forms of generating. That's the one part of it. The other part of it is we're trying to reduce the inefficiencies, if you want to call it like that. And we know in a university context, making hot water for the residences is the biggest form of energy usage on residences, and HVAC on your academic buildings is the other one. And there's a lot that we can do actually to reduce that. We're busy with it, but obviously time and money is always a problem, and you have to schedule this. Just by putting off stuff while you're on holiday or when you're not at home, I think on a larger scale, on a country level, you can make a huge difference. And there's a lot of things we can do, and we must just act to it. And I want to relate it back to the water crisis that we had. When we had the water crisis, we started to blame the government and the province for not having enough water. And we should stop blaming Eskom. We should actually take action in our own hands and make the difference.
Thank you, John. And I think that element of human behavior we can come to in a little bit. I remember I did my thesis on one of the reses at Stellenbosch, Lydia, and looking at everyone wanting to shower and wanting to shower to keep warm during winter. I just thinking back on that now. Lisa, over to you.
Yeah, I think, Georgina, we haven't sort of put this message out, and I think, yeah, John, you hit it on the head. Is as soon as this crisis came, the first instinct was to go to generation. You know, because that's the problem. The problem is we don't have enough electricity, so we must generate more. And people don't understand that, and I think they haven't quite grasped it. If we save energy, and I think you summed it up so well, is that there's possibilities. There's low-hanging fruit. So one of the questions, there's a lot of things we can do. In 2007, Sophia did a paper, and they said if buildings just went to more efficient windows and insulation, which is really quite a low-cost intervention, they could save 72% of a 350 megawatt, 3,500 megawatt power station. And we're talking big numbers. We always look at generation, but if you look at, if we don't need the generation, if we do the energy efficiency, we can save it and save a power station. And Louis touched on, back in the day, I also worked with Eskom on the, not in Eskom, but on the ESCOs and the DSM side, demand side management, the energy efficiency side. And their goal was to build a virtual power station. Now, all we have to do is, as these power stations are dying, we just need to say, okay, we don't need that, those megawatts. And somebody coined it, it's called negawatts, the ones that you don't need, because we're making sure everything's running efficiently, so we don't even need that generation. And that's where I want us to get to.
Thanks, Lisa. So, I mean, I think from all of the speakers, we've heard that, they feel in general that not enough is potentially, being done in terms of raising awareness, and that, it is a significant opportunity that South Africans can explore. So I think I just wanted to quickly touch on costs, because that's often, in our green space, as Lisa would know, it's, the first question we get from our members is, we want to go green regardless of, what the initiative or what the intervention is, but, what does it cost? And there is it's about a 2016-2017 study done by the World Resources Institute that basically demonstrated that building efficiency is the most affordable way to cut emissions. Yep. So, if you look at the building sector as a whole, it's our most feasible way to try and combat climate change. So yes, buildings are part of the problem, but they're also part of the solution. So I just wanted to get that question out, and maybe just get some feedback, and maybe we can start with Grahame and John again, who are on the ground and implementing this at a very practical scale. But do you have any thoughts around costs associated with implementing energy efficiency, but also obviously how that relates back to life cycle costing and benefits? And I think maybe more to Lisa and to Louis, thinking about the green economy. And I know you mentioned that we weren't, you had a comment about the just transition, but energy efficiency is often cited as being a significant promoter of green jobs in comparison to renewables. Yeah, I mean, John, can I start with you?
Yes, Georgina. So we've got intensive programs on the moment, and since 2016 we've actually implemented them, and we've reduced the utility consumption quite drastically. The problem that we've got is the cost didn't change. Well, the cost actually went up, and that is just because of the increase that you get on an annual basis from the municipalities and from Eskom. So it is really a big portion that you have to reduce your consumption to really just to get a flat line on your cost, whether you're going to drop it or going to increase it. So that's a first comment I want to make. The second comment is you need to know what you consume. So where are we consuming that energy? That's the one part of it, and how much. So you really have to meter it. And I think not all of us has got a handle exactly on where we're actually using that inside our buildings and how much our buildings are using. And if you can get that handle to it, then you can start with the calculations that Louis have just mentioned to start to calculate backwards. But on this stage, I think we're not doing well on our energy management on this stage, and we're all trying to get a handle on it first. Yeah.
That's interesting feedback. Grahame, how, just in terms of costs and kind of, paybacks, and how's that playing out in your space?
So it's obviously one of the key factors in making a decision on whether or not to invest in our properties and how to do so is the recoveries of those costs and the returns. So to look at Louis' two components, time and kilowatts, and how that works with regard to costing, kilowatt investment is expensive but easy to implement versus time being cheap but difficult to implement. And what I mean by that is that if you want to do something with a technology, the range of technologies out there is comprehensive and easily available, readily available, I should say, and in many ways proven. So the statements on what it says on the label is clearly communicated. Louis will talk about how well those actually perform in reality. So when I say easy to implement, it's not hard to go and find a tech to fix your problem when it comes to energy efficiency, but it's expensive to implement, and the recovery against that cost becomes our biggest debate. So the capital expenditure is one thing that can be motivated. But then the recovery of that is very different for a property portfolio owner like Growthpoint, which is a real estate investment trust, versus a long-hold property owner like a university. So we need to recover the costs invested within the duration of the time that we plan to hold that property, or the duration of the lease period, which can be quite short. So the costs associated with the technology implementations are quite clearly defined, but our recoveries against those costs are the critical component. Then when it comes to the time, it's extremely difficult to ensure that switch off happens. Even with all of the clever tech that Louis described, with lighting systems that can go through different levels of monitoring systems, those don't always work as planned, and it's the actual implementation of the reduction in time that becomes complicated. So we have property management teams whose responsibilities are very broad, and they have to do a lot of different things. And expectations around energy management programs require dedicated time, effort, and inputs, and in some cases additional training. So the low cost, high cost scenario comes into that debate there, and our efforts are going into how we recover those investments. And I'm happy to elaborate on that a little bit. So I'm going to connect that to the monitoring and verification, or metering, that John just mentioned. So where we have the right kind of information available to us, that's step one in the right direction. We can collect lots of information from our data, from our metering systems. There's lots of that. but how we analyze it and make use of it is the trick. And we would like to be able to ensure that our own people are managing properties with the right information to empower them. There's one of your plays on words, Louis, to empower them to utilize that data set to improve the performance of the building against the key performance indicator that they have for their own performance contracts. That brings a financial element into it, an incentive. Same thing for our tenants through a green lease arrangement. If they're able to receive information from us on a monthly basis, which shows how well they're doing against what was planned for them, and we can share the savings, we start to address that cost recovery problem with the way that our people implement the time saving and the way that our clients implement their own behavioral change. So a bit of a comprehensive response to your questions there, but I was making notes while Louis was talking. I hope that that's come across clearly.
Thanks, Graham. Always appreciated. Louis, from your perspective, have you guys done any research on kind of costs in South Africa with kind of retrofits, and do you have any comments on that?
We have not from the university side done a lot of that, but it's included. There's a economic part where we teach the engineers that understands the engineering kilowatts and kilojoules and terminology. What is the language of the chief financial officer? What is net present value? What is total cost of ownership? What is life cycle cost analysis? So we've put it in all our training to enable the engineer to communicate effectively the financial implications, which is one of the biggest shortcomings of the engineers. They can tell you about megawatts and gigawatts and kilowatts in detail, but they need to translate it into financial calculations. The long and the short is that you do the financial calculation when you do an energy audit on the different possible energy management opportunities, and you make sure that whatever you implement, there's very little risk to implement the engineering solutions, that has a financial benefit to me as well. I still would like to just add one thing to what Grahame has said, and that's on measurement and verification. The question is, what would your bill have been if you have done nothing? And what is the cost of delaying the implementation? So those are the questions that will guide and feed into the financial decisions, because at the end of the day, these are financial decisions that needs to stand on their own. But measurement and verification says, I do a calculation of where I would have been relative to where I am at the moment. And in many cases, that is not done or not done properly. Why? Because companies say to me, Louis, thank you, we've done the course with you, and we can now do energy management, we can do energy audits, we can do measurement and verification. And by the way, we can do it in-house and save some money. Have you realized what is the cost of saving the money by doing it in-house, not getting somebody that is proficient with that? The cost is enormous. And if you look at energy audits, and I've got the things here in front of me, if you look at energy audits, if you have an in-house person walking through your own premises relative to somebody else that is proficient and professional coming with you, the biggest thing, and this is research through in the entire world, is that 80% of opportunities have been missed by the in-house people. 80%, 80% have been missed. So I'm still claiming that by doing proper measurement and verification, you know how much you are saving or calculation of your saving. And secondly, get professional people in, but also train your own people. I cannot think that it's feasible for any company these days not to send some of their people on a multitude of energy management trainings that are available. Not only the ones where I'm involved, there are a lot of them available. And getting the information of how to do energy management. Let me end off with the following. At university, we had thermodynamics and electricity professors, and they did a lot of calculations, and we were all in awe, and we can do the calculations in the exam, and we can pass the exam. But nowhere did they synthesize it. I had to go to industry. I had to go to work for Eskom for 12 years. And my job with Acrelec was to sell electrons, because Eskom had so many electrons, they didn't know what to do with them. They said, we sell. But there, for the first time, I could synthesize how all of this fits together. And I'm saying it will be very good for all engineers and people in energy management to go on some courses to help them remove the rust and to synthesize. And by doing that, they will be able to see the opportunities. The opportunities are there. Not all of them cost a lot of money. There are a lot of low-hanging fruit. And where you have people and you can't change the behavior of people with simple control systems, like an occupancy sensor or a vacancy sensor, you can have a substantial initial effect. Thanks, Georgina. I'm carrying on. I'm so excited about this.
No, it's great. I think the comments have come through from the guests. Thanks, everyone. And I think that everyone's finding your slides and what it is that you're sharing very useful. So definitely keep it coming. But I just also wanted to check in with Lisa just about, the role of efficiency in the green economy. I think.
No, obviously it's huge, and I also want to do a little bit of a sidetrack and say that when we do these calculations, are we using the true cost of energy? So now if you look at the reality of our time now, is you might be using a diesel generator at the moment, and we know that the rand per kilowatt hour for diesel is much higher than the kilowatt hour, because that must be added into the mix. So it changes that sort of payback thing. And what I'd always say is sometimes it's not the cost of energy, it's the cost of not having energy. It's what is that risk to your company? What is, what's the cost to you for not having that generation? And I think, again, and Grahame, you spoke about sort of tenants and things like that. And I think we also almost need to get to a different mindset. John, you spoke about the water crisis. In Cape Town, when Cape Town was approaching day zero, everybody took ownership of their water use. Everybody was I've used this example before. I mean, who knew that we could live on 75 liters of water a day? But people did it, okay? And that's not really water efficiency, that's just water conservation, which is something, a bit different. But I'm saying is we need to look at it and say, guys, if we don't do something, we're approaching day zero with this energy thing. And I don't want to be a doom and gloom person, because I promised that we weren't going to do doom and gloom, because it's in our power, as we started saying, to do something about this. It's because we can reduce the amount of energy that we use. And I think that's also it's so important in the sort of whole green context, is really looking at how much water, how much electricity we use, how much we save, how much we waste. And it is, they say the cheapest energy efficiency intervention you can get is changing people's habits. The hardest energy efficiency intervention you can do is changing people's habits. We need to change, try and get that, to just have a different mindset.
Lisa, can I spent 2 weeks in December in Zimbabwe. 19 hours out of 24, not 19 hours per week, 19 out of 24 hours, no electricity in Zimbabwe in Harare in December. They got a little bit better. I was there 2 weeks ago. It's now down to 18 hours per day, no electricity. You can't run a fridge. You can't keep your food frozen. And now, when I asked them, please, can I just sort of change a little bit my room that is next door to the generator and the vibration? They said, don't worry, we are running out of fuel. We have the money, but we don't have fuel to buy. So the generators are not going to work. So just think of that as a day zero problem for South Africa. And you change your mindset. And then you start to say, even if it costs me more money to do the energy efficiency by kilowatts, if I do that, I will have kilowatts. If I don't do that, I don't have kilowatts. Now that is a crisis in capital letters. Thanks.
I just wanted to get to some of the questions from our listeners. We've got a question here from Abby Godsell. What are the usual low-hanging fruits for increasing efficiency, for example, domestic hot water, that business owners and residents could use as a start on their overall energy use management journey? So, Lisa, if I could direct that one to you first, just for some kind of, also with your experience with the energy efficiency standards and how that's driving change.
One of the, and I think somewhere along we also, I think Abby mentioned hot water heating in residential. It is the biggest user of energy. So obviously, looking at, we really look at passive design as far as low-hanging fruit is what can we put in, and you were sort of low cost and no cost type interventions, things like well, insulation, shading, even things like closing curtains to stop the heat ingress, closing your curtains for the day. There's a lot of things you can do. Turning things off, we have SOS campaigns, switch off something, throughout. I think that's sort of first principles, is even things on standby is turn everything off. And I think there's some easy things to do. I often say to people, sort of traditionally people would grow a tree in their garden for ancestors and past ancestry, and you grow a deciduous tree. In the summer, it's nice and leafy, it shades your house. In the winter, it loses the leaves and allows the sun to come in. So there's so much things that we can do, and really looking at holistically and using the passive design. I would say try and look to where a passive design comes in. Obviously, we can't go totally to passive housing without a bit of cost, but there's a lot of low cost and no cost things that you can do. I hope that's helpful. It's such a broad subject. I can do a lecture on it. I'll be like,
yes. Lisa can do. I've been to some of those lectures before she joined the GBC. But Abby, also a useful kind of guide, and for anybody else on the call who does want an overview of the types of things they could, do. You can also have a look at our certification tools, and it's not necessary that you have to pursue certification, but it will give you the list of initiatives for commercial buildings or for residential buildings. And obviously you then need to apply what is relevant to your context and within the project's specific needs. But that can also give you with that like shopping list of initiatives to implement. But just on that note around initiatives, Louis, there was a question just around the lighting, and I thought maybe you could just quickly clarify. Please expand on the daylighting harvesting in relation to existing light fittings in buildings. Is this some sort of sensor that measures the natural light and reduces the amount of lights on, depending on this reading? And this is from Lucinda Dagula.
It's a very simple concept. Yes, there's a sensor that senses how much daylight enters through a window. And you can have a window and you can have 4 people sitting next to each other, where the person next to the window has got the full daylight, and the last person may have only a part of the daylight. So this sensor senses there's not enough daylight, and let's say Louis sits number 4, and then increases the light with Louis so that he can have 500 lux, but switches off the light incompletely at number 1. So yes, it's a sensor, and it's a little bit more expensive type of sensors because you need now control system to control the lights as well. But that's basically what daylight saving is about. So you want a number of lux. If it comes from the sun and daylight and from windows, you don't need any of the lights. If you're sitting in this area where it's not there, the lights are on there. Thank you.
Here's an interesting, that's actually a comment from Michelle Riverola, but I think it links back to some of the other questions, and it says, using energy costs as the only metric is very narrow and probably an outdated way of looking at energy efficiency investments. Carbon reduction should be factored in more so that there are carbon tax savings which are seldom looked at, ditto if you're a manufacturer, and will be forced with the carbon, excise duties when you have to export to the EU. And, and I think that speaks to the question. There was another question around, what types of incentives or, disincentives from a financial perspective exist for energy efficiency, and maybe if we start off with Grahame and with John, what types of, incentives would you like to see coming through that would promote and enable you and empower you to implement more energy efficiency?
So, Georgina, I think the issue around carbon emissions and linking those to energy efficiency is quite embedded already, particularly in the ESG space. Environmental, social, and governance reporting has required that for some time. Many listed property companies currently measure their carbon emissions and report on those, and divide them into the scope 1, 2, and 3 boundaries. I think one of the difficulties around the incentives is that they nearly always are linked to a tax benefit. And most of the listed property companies that I'm aware of on the JSE are real estate investment trusts. So we do not pay tax, therefore we cannot claim a tax benefit. It comes up a lot, and so we're going to have to review the way that those incentives are made available for the listed property sector separately from many others. Many other property owners are not real estate investment trusts, so they're able to claim those tax benefits. The two that I'm aware of are the Part 12L, which has been around for quite some time, but which is quite a complex process to access that tax benefit. And the other is the more recently introduced solar tax incentive. Again, we don't qualify for either of those. But I'm mixing the two things up around the tax incentive and the carbon emissions. What we're seeing, again, this was a comment rather than a question, but so I'll comment back on it. What we are seeing is that carbon emissions reductions is playing a bigger role in circling back to financial opportunity. So access to capital, or in other words, borrowing money from lenders, is connected to a number of evaluation criteria that any lender would impose on an organization they're going to lend money to. That would be the financial stability of an organization. It might relate to ethics, the ethical practices of an organization. In South Africa, it would be linked to governance structures and BEE ratings, but it's also being linked to environmental criteria related to climate change, and the key one of those is carbon emissions. So carbon emissions and an organization's plans to reduce carbon emissions have become a criteria in access to capital. How expensive the money is that you're borrowing can be dependent on your carbon emissions. So that's a direct link between an energy efficiency measure, reduced energy consumption from fossil fuel-based energy, and the carbon emissions component of an organization. So we are seeing rapidly growing importance of the role of carbon emissions, tracking those and reducing them in the way that we are operating.
Yeah, I think that link with carbon and its relation to how capital is allocated is a key takeaway. John, thoughts from your side?
Yeah, similar to what Grahame just said, is that so we're not a profit-driven organization, so we don't pay tax, so we can't share in any of those incentives. That's the one part of it. The second part of it is obviously we do pay carbon tax, and you put targets and goals in place to reduce that carbon tax, or whatever is going to happen with the carbon tax in the future. If it's going to go over to scope 2, we're all in trouble. The third one is the incentives, and I want to touch something about it. Is that we can actually motivate a lot of our people and our staff to reduce kilowatt as well as the time of that. But how do you incentivize them? That is a difficult calculation you have to do. So everybody will, for monetary value, they will reduce the amount of electricity that we use, but the calculation is the difficult part behind it, and to share that with everybody. Then obviously from our sustainability point of view, we have got a plan in place. We are driving to decarbonize our campuses. Therefore, there's targets in place for 2030 and 2050. And that actually basically speaks to reducing emissions. That is what we want to try and do, is to reduce the greenhouse gas emissions, and then getting to close as carbon neutral or even carbon positive somewhere in the future. Yeah, I think I conclude with those arguments.
Thanks, John. Louis, any thoughts on incentives and different metrics for inclusion in driving energy efficiency?
I would like just to add something to the carbon, and that is that, of course, we report on the triple bottom line, and carbon is included into the mix when you do energy efficiency. So the respondent that made that statement, I agree 100% with them, but of course I didn't address it in this short period of time. On the second one is to get people to change. You can either give them a carrot or you can give them a stick and hit them with a stick. I've done a 2.5-hour session with our university students at the end of last year. Yesterday, I got an invitation to go and talk to some of the hostels here to help them. And the message that I get there is there's no direct incentive for you. However, there is the incentive, which is a bit more of a stick approach, that if there's no electricity left, you won't have any. And I went to the more stick approach to show the people this is not about being incentivized that I can get monetary incentives. This is about surviving in style. So a lot of things, I can give you one example of a hotel in Africa where they just posted on the outside, this is the amount of energy that we use for this hotel. Did you know that? And their energy use went down 45%. 4-5% by just that message. They didn't train the people, they didn't change the kilowatt, they just alerted the people. So by alerting the people to understand that they will have benefit in the global saving of energy has worked. But most certainly, as long as we have people that, and we're not even concerned about incentives, if they don't understand. I was in a building a while ago in Pretoria. Underneath was a heater, an oil fin heater, a nine fin oil heater on. The air conditioning was on. The door was open and both windows were open. And that's the type of thing that we see on a regular basis. People are unaware. So I still believe that one of our easiest and most effective ways would be to alert people to have on an awareness campaign where they are aware how it works. And if necessary, we can put the stick in the back and say, if you're not all going to work together, we will not have electricity. Thank you.
Well, I think that's a valid point. Henk Rotman has just made a comment about, my observation is that the relevance of energy efficiency is limited to a small group of people, and how do we raise awareness of energy efficiency in a broader setting? And I think that you know, obviously for us that are in the kind of green building movement, and we eat, sleep, you know, and breathe all of this stuff, you know, but it seems a few of the thoughts that have come through, a few of the comments that have come through, you know, there seems to be a kind of advocacy role here that maybe, you know, for example, the GBCSA can also obviously support from our perspective. I know, so I'm conscious of time. We've got 10 minutes left, so I think you know, I'll pose one more question to the panel, and then we can close off with, you know, with that as a concluding remark. And so I think the question is around looking into the future. Obviously, everybody is wondering about the energy crisis, and I think that was you, Louis, that mentioned it while we were chatting prior to this about, you know, crystal ball gazing and trying to look into the future and trying to come up with answers. But I think, you know, from all of your perspectives, what do you think the the energy future of South Africa holds, and like what's the one thing from an energy efficiency perspective we should try and implement to make sure that it is maximized and actually does contribute to alleviating some of the pain. Lisa, can I put you in the hot seat? You've always got
Sure.
great ideas.
Yeah, no, and as you know, and I think I'm on this similar sort of vein to Louis. I believe we can make a difference. I think we must get into the solutions-driven mindset that it's not just in Big Brother's hands. We can do something about it. I mean, I've been talking a lot within the building industry to a lot of people and say, and again, if I look at the number of buildings out there, so if we say there's 100,000 office buildings, commercial buildings out there, of those, Green Building Council is approaching certifying 1,000. So there's 99,000 office buildings out there that if each of them saved 10%, which I believe is easy enough to do, we can make a difference. And I'm not asking, and it's not a huge cost stuff. It's it's really looking at all these, some of these factors that we've mentioned. And I believe if we do it collectively, even in housing, if everybody in their house saved 10%, imagine how much in spare capacity we would have. And I think that's the message that I want to give, is it's that South African people are doers and we can do this. And as I said, the incentive is that the proverbial is not going to hit the fan, because we're going to make a difference before it does.
That sounds good. Grahame, what are your closing thoughts?
So I sometimes joke, and I can say it in this forum, that I left my Greenpeace t-shirt at home a long time ago. It's stuck in the bottom of my wardrobe. And I haven't put on a tie yet, but I do work in a corporate environment. And for me, the incentive needs to be money. It needs to be a financial incentive in order to get people to change. If we attach a financial value that is clearly defined, hence kind of frustration around the lack of awareness, will I think be addressed. Humans are by nature driven by crisis and driven by material gain. I think that's a broadly defined and unfair statement to make, but I'll make it anyway. So the crisis is looming, but probably reaction time will be quite slow. So for me, if I, as a property owner, whether that be my own home or my portfolio of properties, or I as a property occupier, be that as a commercial tenant or a residential tenant, have a financial gain that is clearly defined, clearly visible, and clearly accessible, not in some deeply embedded tax incentive, but something that is available immediately, then I will act. So that for me is the transition that we need to make.
Very well put, and I think very clear as well. Louis, what are your thoughts?
I agree that the financial incentive will be the mover and shaker. There's no doubt about it. But I've had a good look at South Africa's policies as well, at our green papers. We have excellent policies. We have excellent plans, but it's not executed. So the first thing is we need to execute the policies. I apologize, and that will come from government. The second thing that I would like to say is, if you don't measure, you know. What you measure, you know, and gets done. But you need to measure it in the right way. So we need to start thinking about the flow of energy, measuring and determining the size of MEDA. And to link on to what Lisa has said, we do not want megawatts to feed our megawatts. So megawatts should not feed megawatts. In other words, we need to decide we don't want the MEDA, we get rid of the MEDA, and automatically the kilowatts and the cost and everything will go down. Thank you.
Thanks, Louis. We're going to get rid of the MEDA. I think that's the takeaway. John, what's your final thought?
Georgina, for me, behavior change is not costing us money. And we know from research 30% of our savings can come from behavior change. So let's work on it, and we make a plan around incentivizing it. The other part of it is we all have got data. Start measuring it and analyzing your data and investigate it. And then you identify the low-hanging fruit and you actually action it and you change it. And you put interventions in place. And then I think what Louis have also said just right now as well, get the wastage out of the system. There's a lot of wastage in our systems. And the one big point that I want to bring out is that we must work together in the sense of work together with your local government, with, in our case, the municipalities, because they're putting plans in together. And if you've got a few companies working together with your municipalities, you can actually take this to a much broader scale, and basically you get the returns on investment from that. And we must use organizations like GBCSA and our bigger organizations and just get the awareness out there and help the people to mobilize and to action there.
Thanks, John. No, we definitely are all stronger together. And, you know, so with that, I think I'm going to say thank you to all of the panelists for your very insightful and I think practical on the ground feedback and insights around, you know, some of the challenges and the opportunities. So a big thank you to Louis and to Grahame and to John and to Lisa for all of the insights today. And a big thank you to all of our listeners for your comments. It seemed to have been well received. There were, you know, there were questions, but there were also just a lot of comments that the presentation was very helpful and insightful. So I think that, you know, there are some key messages, some key takeaways also for us as the Green Building Council, you know, from this session. And I think that there were some solutions that were posed. I think that, you know, a great focus on the session was that it was solutions based and kind of looking at how not to be powerless and not to feel hopeless about the situation, knowing that there are many layers in this debate. But yeah, so please go out and do what you can, fight the good fight. Thank you very much for joining us for today's session. And we're just going to end off with a convention video, which is taking this place at the end of this year in November. It's on the 15th to the 17th. And we are hopefully going to see you there. So thank you and goodbye, everyone.